Hello all. In today's session of Metrology and Instrumentation, we will be discussing motion and dimensional measurements. In the previous classes, we have seen various types of measuring instruments, their performance characteristics, transducers and different types of transducers, etc. From here onwards, from this class onwards, we will be seeing measurement of various physical parameters. So in this class we'll see a method of measuring motion and a dimension measurement. Usually we need to measure displacement or dimension. So they are linear measurements, and one very common device used for such measurement is LVDT. LVDT is linear variable differential transformer, or it is also called as linear variable differential transducer also. Actually, so this is a transducer. It's a passive transducer, and LVDT is the most widely used inductive transducer to translate linear motion to electrical signal. So it is simply a transducer that converts the linear motion into electrical signal. This figure shows the circuit of LVDT. Actually, an LVDT is having a primary winding. So a primary winding like this is there in LVDT, where we are providing AC power source. Then it has two secondary windings like this. The secondary windings are the number of turns in both secondary windings are equal, and they are also placed equidistant from the primary winding. We will see the construction in the next slide. This is the circuit. So it has a primary winding, then two secondary winding of equal number of turns. Another component is a core. This is a ferromagnetic core, and this core will move left and right inside or here. So this is the circuit. Now in the next slide we will see the arrangement or construction of LVDT. This figure shows the construction of LVDT. In the previous slide we have seen the circuit. It is having one primary winding, two secondary windings and a core. So this is how it is arranged. We can see that this is the primary winding to which we are giving AC power source, and these are the two secondary windings. So we can see that this primary and two secondary windings are coaxially placed, and you can see that it is coaxially placed or wound over a hollow cylinder. This is a hollow cylinder, and inside the hollow cylinder we have seen a movable ferromagnetic core. So this ferromagnetic core can be moved left or right inside this cylinder, and the secondary windings, secondary winding 1 and secondary winding 2 of equal number of turns are connected in series like this. Now let us see how an LVDT works. So we have seen that this is a construction or arrangement of LVDT. So this is the primary coil and these two are secondary coil, and this is the core. So when the the primary circuit is excited by AC current, the AC current starts flowing through the circuit, and a magnetic field is created in the primary circuit. So when the magnetic field interact with the secondary windings, EMF is also induced in the two secondary windings. When the core is equidistant from two secondary windings, the net the uh, EMF produced in two windings will be equal. So the net EMF will be equal to 0. So this position of the core is known as null position. Now if you move the core to the right, the EMF induced with the secondary coil, that is ES2, will increase. So this will be the condition. ES2 will be greater than ES1. And the net EMF shows a negative value. Similarly, if you move the core towards the left position, the EMF induced in the first or this secondary coil will be more. So yes, this EMF will be greater. ES1 will be greater than ES2, and the net EMF will be a positive value. So the LVDT uses or like this you can so by comparing the magnitude and phase of output with the input source, the amount and direction of movement of the core and the displacement may be determined by the LVDT. That means according to the position of the core, uh, the corresponding signal is obtained, and the corresponding position can be determined. Usually that core will be connected to or core will be connected to the sensor. So as the sensor moves, the core will move left and right inside the coil, and the position of the sensor can be determined by the method. And this LVDT is having very good advantages, like it possesses very high sensitivity, and another advantage is these transducers have low hysteresis, and repeatability is excellent under all condition. Another advantage is it is having infinite resolution, and an advantage that makes the LVDT very common is it is very simple, light in weight, and easy to maintain. It is also having some drawbacks, like it is very sensitive to stray magnetic fields, but it can be avoided by proper shielding. Then another drawback is they are inherently low in power output. And one more disadvantage is the atmospheric temperature will affect the performance of the transducer. Now the application of LVDT. LVDT is widely used for measurement applications. It can be used to measure displacement ranging from a fraction of a millimeter to a few centimeter. And another application is it is also used as a secondary transducer for measuring force, weight, pressure, etc. And that's all about the working and construction of LVDT, and also the dimension measurement. So that's all about so we have completed module 5, and in the next session onwards we'll start module 6. The module 6 also deals with measurements of various parameters. Thank you.